I usually start this problem out with a side question where I'd say, hey, guys, if I have something that looks like that and I say solve for x, can you do this? And most times they'll go through this process pretty easily and they'll wonder why we're doing some Algebra 1 in an Algebra 2 class. Well, ultimately x equals 1/2, right? And that's what we get there. The reason I go through that exercise is it's the same thing here. Don't let this freak you out that you've got cosine, you've got numbers. Do exactly what we did here with this, but just treat cosine of theta as the variable. Okay, so we're going to add 1 to both sides. So that's a 3. And you have 6 times the cosine theta equals 3. We'll divide by 6 and you get cosine theta equals 1/2. Okay, and now this should be stated here. It says 0 degrees to 360 degrees. It's important that we understand that that means that we're just simply talking about one rotation around the unit circle, and that assumes that we're using degrees. Well, as we see here, that we should also have a side note that that theta should also be recognized to be between 0 and 2 pi, depending on which question is being asked, whether it's this one or that one. So as we see here, for radians, that just means within the context of the unit circle, cosine is positive 1/2, is only positive in the first quadrant and the fourth quadrant. So if we're looking at this and we're creating triangles in the first and fourth quadrant, if I'm only traveling over 1/2, that means I'm creating a tall triangle in the first and the fourth quadrant. That's what this is saying. Cosine's x, so that's left, right. 1/2 is positive, so it's only to the right. Okay, so a tall triangle in the first and the fourth quadrant in radians means that we're going to have a denominator of 3. And that's going to happen twice. Okay, the first quadrant version is just pi over 3, and that's pretty basic. The fourth quadrant version, if you know your unit circle, is 1 pi over 3, 2 pi over 3, 3 pi over 3, which reduces, 4 pi over 3, and then over here you have your 5 pi over 3. So those are the two answers that we're looking for in that particular case. You start looking at some other things like 5 down here, and I'm jumping to another radian measure. But something like this where you've got cosines on both sides, don't forget there's just 1's out in front. So if I want to add a cosine to both sides, get to consolidate my cosines, that's a COS. Now I've got 2 cosine. Theta equals the square root of 2, and that might look nerve-wracking at first because square roots are scary or whatever. You divide by 2 though, you get cosine equals 1 root 2 over 2. Well, again, that on the unit circle, that's positive cosine. It's in the first and fourth quadrant, but this time root 2 over 2, it's the 45-degree angle. And so you're looking at pi over 4, and the fourth quadrant version is 7 pi over 4. All right. Yeah. Then you get down to stuff like this. These are kind of kooky. Something like sine squared equals 1. Well, I go back to this. What's x squared equals 1? You take the square root of both sides and you say x equals 1. Yeah, that's great. But don't forget, when you take the square root, you've got to consider the fact that it's a plus or minus. Same thing here. When you take the square root, yes, you do get the sine theta, but it should be equal to a plus or minus 1. Back to the unit circle. Sine being plus or minus 1 means we're heading either up or down, a total of 1. That means we're in the transition from quadrants 1 to 2, and then from quadrants 3 to 4, and that's a pi over 2, and that's a 3 pi over 2. And finally, in terms of examples, I have secant equaling 2. Don't forget, secant is equal to 1 over cosine. So that means if I say cosine of theta, I'm going to just say cosine theta is equal to something different than 2. If I'm saying cosine regular, cosine is 1 over secant, so cosine should equal 1 over 2. We already did that one earlier today, so I'm going to let you do that, but I'll do it in degrees.